Okay, Assalamualaikum and good afternoon. Today I will present my final year project in topic the influence of rubber granular as fine aggregate in concrete pavement. My name is Isma Aida Akma binti Ismail and my supervisor name is Dr. Ramadan Shah Putrajaya. The outlines of presentation is introduction and background, problem statement, objective, scope of study, literature review, methodology, results and discussion, conclusion, recommendation and reference. First is introduction and background of study. Worldwide use of rubber products are increasing every year. Waste rubber can be used as a replacement of fine aggregate in concrete pavement for use roadways and walkways. Replacing a portion of fine aggregate with rubber granular raised concern regarding the generate shrinkage and cracking of rubberized pavement concrete. It was reported that the high content of rubber reduced as high as 90% of the compressive strength of rubberized pavement concrete compared to control sample of pavement concrete without rubber. Problem statement is waste tires occupy large landfill space that contain nesting insects and rats. Billions of tires now reside in landfills and illegal dumps around the world, causing pollution from the release of toxic chemicals and the potential for health risks from the breeding of mosquitoes in trapped water. In order to reduce unnecessary landfill and preserve the environment, recycled tires can feasibly be used in the pavement industry. The objective is to study the strength properties of rubber granular as fine aggregate in rigid pavement, then to investigate the optimum percentage of rubber granular as fine aggregate in rigid pavement. The scope of study is focused on crumb rubber concrete, which has provided information regarding rubberized concrete used as pavement applications. In order to minimize the negative effect of adding rubber into the concrete pavement, crumb rubber in the particle size range of 1 to 4 mm was selected. Rubber content with proportion 3%, 6% and 9% as fine aggregate in concrete pavement. The effects of the crumb rubber inclusion were assessed by comparing mix to a control mix without rubber, which is 0% of rubber content. This is the literature review and the methodology. First, the sample preparation of coarse aggregate, fine aggregate, rubber granular, ordinary Portland cement and water. Then we will sieve, then mix the material and put in the cube mold in size 100 centimeter cube. Then curing in water for 7 days, 14 days and 28 days. The test we will perform is compressive strength, ultrasonic pulse velocity, skid resistance, permeability, density. The mix, we will mix the concrete by laboratory batch mixer. Sampling the cube for test, store in moist air for 24 hours. Then we will curing the cubes in water for 7 days, 14 days and 28 days. Then we will concrete cube test with compressive strength test, ultrasonic pulse velocity, velocity test, skid resistance test, permeability test and density test. Then this is the result on discussion. To assess the effectiveness of the addition of rubber granular into the concrete pavement, the properties of rubber granular were evaluated at different ages, and the results are present in the table and the graph. It was observed that the improvement of concrete pavement was more significant on the 3% of rubber granular rather than 0%, 6% and 9% of rubber granular. Then this is skid resistance test. Measurement of skid resistance of the concrete pavement have shown in the table. The good surface of concrete pavement must be above than 55. to have the good level measurement of skid resistance, the choice of fine aggregate has a major effect on the results. From the results in the table, it can conclude that more addition of rubber granular in the concrete pavement, it can be more effective to the surface of the pavement. Then this is ultrasonic pulse velocity test. Based on ultrasonic pulse velocity test result, for 0% and 3% rubber granular added into concrete pavement is increased with increase in curing age, while 6% and 9% of rubber granular is decreased with increase of curing age. Due to the fact that the more contribution of rubber granular in concrete pavement even at 28 days of curing, the UPV test value will lower. Then for permeability test, the water passed through the pavement concrete is being recorded in the table. The table shows that the time recorded is decreased when the percentage of crumb rubber is increased, which is 0%, 3%, 6%, and 9% due to 7 days, 14 days, and 28 days. This happened because the crumb rubber size is bigger than fine aggregate size, so it have the airways inside the pavement concrete. The water can flow fastly and easily through the rubberized concrete pavement. Last is density test. The density of pavement concrete made with different replacement level of crumb rubber 0%, 3%, 6%, and 9% with age 7 days, 14 days, and 28 days curing respectively are given in the table. All concrete pavement cubes produced fall within the range of 1.1 gram per centimeter cube to 1.3 gram per centimeter cube. The density of all the cubes are not fell within the normal range of concrete pavement, which is the normal range is 2.2 gram per centimeter cube to 2.6 gram per centimeter cube. The result is present in the graph. So the conclusion, the compressive strength of the concrete pavement is reduced as increased the percentage of rubber granular in the concrete pavement. But at 3% replacement of rubber granular, the compressive strength increased with the compression of 0% of rubber granular. The optimum percentage of rubber granular as fine aggregate in concrete pavement is at 3%. For the recommendation, it is recommend to concrete pavement is containing crumb rubber up to 3%, which is expected to achieve a target compressive strength of not less than 30 megapascal at the age of 28 days. It is also suggested that crumb rubber could be used in traffic, pavement, sidewalks, playground, and so on by other applications. Rubber has property of sound absorption, which also help in reducing the sound pollution of heavy traffic roads. The use of rubber can improve the quality and performance of road. Also can be save a certain quantity of natural stone aggregate. This is my references, and thank you.